Hi students, in this video we're going to learn about blood grouping systems. There are various blood grouping systems, but ABO blood grouping system is the most important one. So other blood grouping systems are like UV system, MNS system, but they are not clinically relevant. So let's learn about ABO blood grouping system. The four different blood groups are group A, B, AB and O. And this blood grouping system was discovered by Karl Landsteiner and he won Nobel Prize for this discovery. And according to Landsteiner, he proposed two laws. It's called as Landsteiner's laws. So what are the two Landsteiner's law? So on the right panel, you can see a blood vessel. There's an RBC and serum. If a particular antigen is present on the RBC, the corresponding antibody must be absent in the serum. This is the first law. If an antigen is present on the RBC, the corresponding antibody must be absent in the serum. What is his second law? Just the opposite. If a particular antigen is absent in the RBC, if an antigen is absent in the RBC, the corresponding antibody must be present in the serum. Serum or plasma, both are same. So these two are called as Landsteiner's law. So according to this, let's look at the blood grouping systems. Blood group A, it has A antigen on the RBCs. The corresponding antibody is absent on the serum. That's why it has anti-B antibody in the serum. So the genotype can be AA or AO. Blood group B. B antigen is present on the RBCs. The corresponding antibody is absent, but anti-A is present. So the anti-A antibody is present in the serum. The genotype could be BB or BO. AB blood group. Both A antigen and B antigen are present on the RBCs. If both antigens are present, the corresponding antibodies should be absent in the serum. That's why no antibodies are seen. The genotype is AB. O blood group, A antigen, B antigen, both are absent. If the antigen is absent, the corresponding antibody should be present in the plasma or serum. That's why it has anti-A and anti-B antibody. The genotype is OO. So AB blood group, they are called as universal recipients because they can accept blood from any group. The reason is that they don't have antibodies in the serum, so it cannot react. O group is called as universal donors because they do not have any antigens. So they can give blood to any group because they don't have antigen. When they give the blood to other group also, there's not going to be any reaction there. That's why they are called universal donors. RH grouping. The RH grouping is different from ABO grouping. RH grouping is going to determine whether you are positive or negative. For example, A positive, A negative, O positive, O negative. So that positivity or negativity is determined by this RH. So what is RH? RH is actually a D antigen which is present on the RBCs. It's called RH because Landsteiner discovered this for the first time in rhesus monkeys. That's why he gave the name RH factor from rhesus monkey. So if you have antigen D, you will become RH positive, or A positive, B positive, O positive, etc. If D antigen is absent, then you become negative blood group. RH incompatibility. This is very important on the clinical side. So we have a pregnant mother here. The mother is RH negative. The first baby, so this is the first baby. The baby is RH positive. So now what happens? The baby, RH positive baby, can produce RH antigens. But these antigens, they do not cross the placenta. So they cannot go into the mother because they don't cross the placenta. So at the time of delivery, baby has no effects. It's just born normally. But if the mother conceives for the second time, there is problem for the second baby. Why? because when the mother was pregnant for the first time, the first baby did not have any problem because antigen from the baby did not go into the mother. There were no reactions. The baby was normal. But at the time of first delivery, when the baby was born, during the process of delivery, there's breakage of membranes, and at the time of delivery, this antigen, Rh antigen from the baby could have been passed into the mother. So during the first delivery, antigens go into the mother, and these antigens, maybe after 1 or 2 months, they form antibodies in the mother. So now Rh antibodies are formed in the mother. If the mother conceives for the second time, the formed Rh antibodies, they cross the placenta and reach the baby. So the second baby is going to get into trouble because the antibodies from the mother, they pass through the placenta, reach the baby. There are already antigens in the positive baby, so antibody antigen reaction will take place, agglutination reactions, and total hemolysis in the baby. The baby goes for hemolysis. It's in danger now. So this is called as erythroblastosis fetalis. So you find that Rh antigens, they do not cross the placenta. They have gone into the mother only at the time of delivery when there was breakage of membranes, but they didn't cross the placenta. But Rh antibodies, they can cross the placenta and come from mother to the baby. So Rh antigens don't cross placenta, but Rh antibody, they can cross the placenta. And this baby now suffers from erythroblastosis fetalis. So the presentations are severe anemia. Why there's anemia? Because of hemolysis. You have anemia, and all hemolysis can release increased levels of bilirubins, which can go into the brain of the baby, damage the brain, thereby causing kernicterus stress. And hemolysis also results in edema. See, look at the abdomen and the face, it's edematous, swelling. It can result in edema. This is called as hydrops fetalis. So the baby suffers from all this, and it's very difficult to treat this kind of an erythroblastosis fetalis. So this completes ABO blood grouping systems. So with this, we complete the discussion of blood physiology, and let's move on to few neat and next based questions from this.